Hello everyone, welcome back to this Beckhoff TwinCAT 3 motion control series video. And in this video, I will show how can we connect our axis. This physical axis connecting the step motor with the encoder, this precision loop control with our program. Basically, we will connect the physical axis, this physical axis to the logic, the program. For example, reset, power on, home, jog, allows the program to control our physical axis. And in this axis, I'm using the step motor KL2541 with the encoder, that is the incremental encoder. And this video will based on the couple videos before in this series video. Firstly, I would recommend you need to review a couple videos before. One is how can we set up the axis, how we did the parameter setting for the encoder, drive, as well as the control parameter. And in this axis, I'm using the 2K, this closed loop controller, and for the standstill K, I'm using 8. And for the moving, I'm using 10. And for the incremental encoder, I set 1 revolution, that is 360. I assume the degree equal to millimeter. My encoder, that is 1024 lines. And because of the module, we need 4 times setting associated with your incremental encoder. That's why here I set 4096. Don't forget this 4 times relationship here. And the drive, I'm using step motor. And for the step motor, we need to set something for the register value. From this KL2441, go up 1 layer, go back to the BK1120, this EtherCAT interface. Right click, click this register access. Now we are in run mode. Okay, I'm gonna switch to the config mode. And then we can activate the free run mode. And from this interface here, click this register access. Then select the KL2541. There are a couple important parameters setting here. For example, how many lines per revolution for your step motor. In this case, I'm using Beckhoff step motor. That is 200 lines per revolution. And this is the incremental encoder. How many lines per revolution from the incremental encoder? 1024. Okay, this is the current setting. Also, don't forget the micro step. That is 2 power 6. That is 64 times micro steps. Okay, this is the EL2541 settings. And this is the axis setting here. And also, you probably need to record some videos in this motion control series video. That time, I discussed how can we program the function block. For example, in this case, in my project, I set up this ladder logic, okay? And I use this function block, MC reset, MC power, MC home, MC jog. To review the videos talking about those function block programming, you can go to my channel, search electrical automation hands-on, and then go to my channel, electrical automation hands-on. And then go to playlist, find out the motion control, or find out Beckhoff TwinCAT controls. For example, let's go to motion control. And in this motion control, this playlist, I talked about the Siemens motion control, Allen Bradley motion control, as well as TwinCAT 3 motion control. And from this TwinCAT 3 motion control, there are main 2 playlists. One is from MB01 to MB10. That mainly talk about the program for control the virtual axis. That time I discussed how can we use the motion instructions, reset, power, home, and how can we control the axis using MC, velocity, relative move, and absolute move. And that is from MB01 basically to MB07. Okay, and then from the recent series video, I start from the MB08. We talk about the actual physical motion control axis. I'm using step motor, Beckhoff step motor motion control. Also, we are using KL2541. I'm using step motor as a closed loop, that the position feedback. So, you probably need to review a couple videos before. Okay? And currently from this device, this EtherCAT device, this KL2541, we are using the BK1120 as a EtherCAT this station. And in this station, there are one module KL2541. And for the controller, I'm using my laptop. And my laptop is connecting with this BK1120 using the Ethernet cable. But the protocol, we are using the EtherCAT because this is a BK1120. That's the EtherCAT station interface module. And we test the hardware connection. We used this access, set up the access, set up the parameter. And don't forget from this access, if we download the hardware and then we switch to online. For example, now if I click this downstairs, download all the hardware configuration, and switch the system to run mode. Now we haven't downloaded the program yet. This is only the hardware portion. And then we go to the access. Then we click this access and go to online. And now we can use this panel to control our access. For example, now I click this set. If I set 720, let me click yes. After we use the panel to optimize our closed loop control, once you think this motion control, position, and the speed, that totally makes sense. Now we can shift to the program. I will use the program to control our access. And to quickly review our program setup, the basic function block to control the access, we will use MC reset for resetting the fault, MC power to control the power to the access, MC home to home the sensor, and MC jog. We can jog forward or jog backward, manually move the access. And to use the program to automatically control the access, probably we will use MC velocity, MC relative move, and MC move absolute. To stop the motor, we could use MC halt and MC stop. And in this video, I will show the basic control, MC power, MC jog, and MC halt and stop. Okay? And how can we connect one physical access from this access here to our logic? How the program know now we are controlling this access, right? The key answer, that is this. This is one access value we declared. So from this programming wise, under the PLC folder here, under the GVL, and I declared a name the single access. This is a variable name, but this variable date type, this is the keyword, access underscore ref. Once we declare one variable, single access, this variable name as this, then it allows us to connect this variable at our access, this configuration here. Go to access, go to setting here. And from our program, if this function block, this access connecting this single access, this variable name, that means this function block will control this logic access. And then this logic access will be connected to this physical access here. So this variable will use as a bridge connecting our program to the physical access. This is the main idea. So now, how can we connect this declared, this variable name to our access? Then let's go to our access here. So if you recall, at this link to I/O here, that allows this access know what the physical hardware is connecting. It named terminal 6 KL2541. If we go down, so it terminal 6, the terminal 6 KL25 is here. So this logic access know, okay, the hardware, this access is connecting this hardware at here. So what the logic, the software access is that single access we declare. So from this link to PLC, we can click, we can see, because we only declared one variable name, date type, that is the access underscore ref. So that's why it only pop up one. If from this GVL, for example, we have a 3 axis, so we will declare 3 line here with a different variable name, but their date type, they all access underscore ref. Then that time, if we go to the access, click this link to PLC, it will pop up 3 variable name that date type that is access underscore ref. Okay, so we go here, click OK. So once we connect here, that means logic-wise is connecting this variable. We will use the program because all program, every function block, we are connecting this variable name, single access. So all the function block, when it's fire or home the access, though the command will go to this physical access here. So now this link to PLC we config here. Then we need to download this active configuration. Also, we will download the program because all those programs we are connecting this variable name. So now once we download the program, we can reset the fault, we can home or power on this access. Okay, and quickly review our program. Again, to reveal how can we program those function block, you go to my channel and review from MB01 to MB07. Okay, let's go to the main. So from this main, we call this program motion control. And this motion control call this ladder logic, this method. Okay, and then inside this method, I defined as a ladder logic program style. So from the top line, MC reset is connecting this single access, this logic name. And don't forget this prefix name that come from this page name is named the GVL_SA. Okay, and this is the command variable, bool variable. Okay, so now let's try if this program can power on this access. Now let's go up and then let me download active configuration. Okay, once you see this screen, hardware portion is running. Now we need to download the program. Click this PLC here, click this login. Login means we download the program. Okay, so now this program is running. And at the same time, I can go to the access. We can turn on that online. So I can drag it, make it float. So we know this access value. Also, we know what the actual speed is running. Meantime, we can also use the watch list. So go to PLC, click watch 1. To monitor the access speed, velocity, and the position value. So we can type in the access, this variable, GVL_SA, right? Dot the single access. This is our access name, and let's find out the actual velocity and the actual position. So that is NC to PLC, and then select the actual position. Okay, and then select the actual velocity. So now we can see the actual position now, that is 13.27. They are the same. Velocity, that's 0. Okay. And now let's power on this access. So we can see now this enabling, this checkbox now is empty. Once we download the program, we cannot control here anymore. We cannot control here. So because the program is controlling this. So now we can enable this access. So we can turn on, enable positive, enable negative. Enable which direction, it depends on your application. Okay, click this right value. Okay, now we enable this access. Override, don't forget default. If without any override setting, we should set 100. If by default it's set 0, your access won't move because you will override 0 speed or 0 velocity setting to your access. The access won't move. Don't forget this. That's why from this panel, when we click this set, if you click this all, the default override value will be set 100. Okay, don't forget this. If you want to override with the very slow speed for testing purpose to protect the mechanical or protect the motor, so you can set a very low value. This is the same idea as the robot. You can set a slow speed after you touch up, and then you can try 1 or 2 cycles for testing the path and testing if the robot is doing properly job. Okay, so we can click this right value. Now this access is enabled. Okay, the value now is at 13, so we can set a 0. Set 0, we can store down, and using this MC home. How to set the encoder set 0 or allows the access go back to home using the sequence. I will specially use one video after to show this. Temporarily, I'm using MC direct. This home mode is a MC direct. That means once we set value, boom, this value directly into this access. And the setting for the position, I set 0 here. Okay, and once I turn on this home access, so this value will be override to 0. Okay, we can see the position value set to 0. Okay, now we got a power on. Also, we can see this status here. So the motor is enabled. That's why this power status active shows on. And now we can use this MC jog to manually move the axis. And from this MC jog, when we jog the axis, definitely we need acceleration, deceleration, and this velocity setting, right? By default, if all those values set as a 0 here, that means this setting here will use the axis default setting. Here, if we go to here, go to the parameter here, so all the value will use the default value at here. If the jog move 100, probably that is too slow. I can speed up a little bit. For example, I can set to 300. For setting this default value, I can click this enter. We can see the 100 here shows red. That means the offline, online, they are not matched. So I can click this line and click this download. Download this axis parameter setting. Now this axis is set at 300. Okay. This is velocity. Okay. Now we can click this jog forward and jog reverse. So we can command this jog forward and jog reverse. Probably these two variables will be connected to two buttons on your HMI. That means the jog forward and jog reverse, right? So we click this online, we can monitor the axis value. Also, we can monitor the axis from here. Okay, now if I turn on this jog, usually this jog command, they are momentary button on your HMI. So when we turn on, this axis will go positive direction. Okay, and if you release this button, turn off this button, the axis will stop. Okay, it has a deceleration. Okay, if I turn on this jog reverse, it will go to the backward direction. And in the meantime, we can see the speed, that is minus this velocity. Okay, release the jog. Okay, so this is MC jog. Meantime, we can watch the output status. So turn on this jog forward. We can see the active shows true. Turn this off. When the axis totally stops, so this active will go off. Turn on this reverse. Release this reverse. We can see. Even I turn this off, but if the axis still moving, slow down, so this active still on. When the axis totally stop or stand still, this active turns off. Alright, this is manually jog move the axis. And then let's go to MC velocity. From this MC velocity, it has a velocity setting, acceleration, and a deceleration setting. And from this direction, we can control is moving to the positive or moving to the negative direction. Okay, so from here, if I set, let's say 500, let's run a slightly faster, and I will use the default acceleration and deceleration. Don't forget that acceleration and deceleration, we can set that default value from this parameter here, acceleration and deceleration. And now I set 500 velocity, positive, and let's trigger this move. And let's watch this set point velocity. So now this axis is running at 500 millimeters per second, which is very fast. If now I turn off this MC move velocity, we can see this axis is still moving. To stop axis, we have to use MC halt or MC stop. If I scroll down, MC halt, MC stop. If I turn on this MC halt, so this axis will slow down and stop. Okay? If I release this MC halt, this execute, that's the rising edge command. Once we turn on, got this rising edge, this axis will stop. If meantime we got the second move command turn on, this axis will still on. So this MC halt, it will be only execute while it's getting the rising edge execute.
If you try to hold the axis, to stop the axis, so probably you need to use the MC underscore stop. If this stop execute turn on always, so this axis won't be moved. Okay, if I turn on this, let me see this. So now we are holding this axis. So if I trigger again this MC velocity, so we can see it shows arrow. The axis won't move because MC stop is enabling. Okay, and if I release this MC velocity, this arrow will gone. And if we got some arrow here, don't forget we have a MC reset. We can turn on this execute to reset the axis fault. Okay. Okay. Now let me scroll down. MC stop. Let me release. Okay. I will try again. Move velocity. This time I will move another direction. So here I can pick this negative direction. This value is still 5, but direction will be totally reversed. Okay, now I will trigger. And you can watch this speed here, this velocity, actual velocity. Turn on. So we can see it go to the negative 500. The actual speed is showing the vibrating. That depends on how you optimize your axis. Okay, also we can see the set point, it goes to minus 500. And this is the actual position. If I release, it's still moving because this is speed control, right? So to stop the axis, we can turn on this MC halt using the rising edge. Okay, that allows us to stop the axis.
So this is the basic control. We can manually control the axis using MC underscore jog or speed control, that's a move velocity. And in next video, I will show how can we use the move relative and the move absolute. Meantime, I will set up the trend. I will use from here, if we create a new project, and I will use the TwinCAT measurement, we will set up the YT scope, this project, so we can monitor the actual position and the actual velocity using the trend. And I will show how can we trigger the move relative and the move absolute. After all, in the automatic control, the 80% command we will use, that is a relative and absolute position control. Alright, see you in next video. Thank you for watching. If you like this video, please give me a thumb up. If you like to watch more videos in my channel, please subscribe and hit the bell. Thank you for watching.